Now we're going to look into a really fascinating implication of Hubble's observation that further away galaxies are moving away from us more quickly. Let's just draw out this diagram again. So when we look at nearby galaxies, we see them moving away from us relatively slowly. When we look at further away galaxies, we see them moving away more quickly. And it doesn't matter which direction in the universe we're looking when we see this effect. I want you to think really carefully about the fact that this is actually moving all the time. All of these galaxies are moving. And let's just go backwards in time. Let's rewind this movement of the galaxies, because this tells us about the origin of the universe. So it's interesting to see where these paths lead. Where would these galaxies be if we look back a little bit earlier in time? Well, this one is moving at a medium-sized speed, so that will be moved in to about here. This one's moving very quickly, so that one will have moved quite a long way. And this one's moving relatively slowly, so it's just moved in a little bit. So what's happened? All of the galaxies have moved back towards this central point. All of the galaxies have moved closer together. Let's go back a step further in time. We make these galaxies continue with their velocity towards each other. We're traveling back in time, so instead of moving away, they're moving towards each other. And we end up with one galaxy here, one galaxy here, and one galaxy here. So the implication of the movement of galaxies that we see today is that if we rewind that motion, every galaxy in the universe gets closer and closer together until they actually end up occupying the same point. So this is where we get the idea of cosmic expansion from, but it's also where we get the idea of the Big Bang from. This theory that everything in the universe initiated in one point at some point in the past. Not only does this observation imply that the universe had a definite beginning, that everything started from one position, but we can even use this data to work out the age of the universe. So how do we actually use the information that Hubble found to work out how old the universe is? Well, we need some measure of distance. And for these huge distances that are involved, for the distances to galaxies, millions of light years, we often use a measurement called the megaparsec, which we abbreviate to big M PC. How fast would a galaxy exactly 1 megaparsec away be travelling relative to us? Our best measurement for this is around about 70 kilometers per second. So working out the age of the universe is actually incredibly simple. All you need to know is how many kilometers there are in a megaparsec. Then you work out how many seconds it would take you, traveling at 70 kilometers every second, to travel a megaparsec. And this will give you the amount of time it would take this galaxy moving at this velocity to move back to this position, or the amount of time it would take this galaxy moving at this velocity to move back to the central position. And all of them would arrive at the central position at the same time.